we are going to talk about another skill. It's called integration by parts. On your section 3.5, page 86. Earlier, we were talking about integration by substitution, right? In your section 3.4, if we have, say, xe to the x squared dx, then we can say this one is your u, then that's the derivative of u du, then you can integrate back, right? However, like this one, we can use what? Substitution, right? Then, however, if we have e to the ex dx, like this, then this one, if you take a derivative of this, it's ex itself. So that's by itself can be integrated. But you have something extra here, it's not any derivative of those, then you cannot integrate back. So we cannot use substitution to do it. Okay? There is another way called integration by parts. And for most of you, it will be super confusing for this part. Okay? And in real life, you may never use it. But some of you may go, higher to do more study on the economies or, more calculus. Then you might use it. The integration by parts, the formula is like this. U dv equals uv minus v du. Here, we just use one sub as u to replace. Then we can make it simpler. Then becomes what? Antiderivative, right? Become a single thing, because that would be what? This one, remember, u is x squared, then du would be what? 2x dx, right? Then you replace this part, so x dx will be half of u, so you end up to e to the u, then half of du from your previous section, right? Because x dx becomes half of a du. Then what do you have? You have a half eu to the du. Then you can integrate eu du by the exponential function rule, right? Because it's a single element, you can do antiderivative. Because this u can take derivative, become the rest of them. But here, e to the x power is e to the x power. Then you take derivative, there is no extra x for you to use. So you cannot use the substitution to do it. Then we have to use something like this. U dv equals uv minus integral of v du. Okay? And it's super confusing how we get here. All right? We are going to talk about reasoning. And if you have difficulty for the reasoning, you need to remember this formula. Even you skip this part, you can still get your A, B, C but you have to do everything else right. Okay? So, but it is manageable. We have to use different thinking and different symbols called what? We are going to using the differential symbols to help us to do this. That means we use different kind of tools, okay, for these advanced skills. So like here, we just use one U to sub in, then that's fine. But this one, we have to use two parts, U and V. Okay, so we have U. U means what? U of X, some kind of X, right? Then V is what? V of X is some kind of X. Then how we are going to use differential symbol? Okay, so when we have f of x, right? When we take a derivative, that would be what? F prime of x, right? Against the x. This one, we use what? Derivative symbol to do that. Then another way to write it in previous section, we say, okay, I'm going to write this just as a differential. I'm going to use just df. df for the f of x means this thing. They are the same. They are the same. We are going to use different symbol. Okay? So it means this way as well. If we use the different symbol to do that, it means what? df equals f prime of x of dx. Right? Or we can write it this way. Okay? Or we write it this way. df, differential of f means what? F prime in dx. Right? Because f prime is the f prime of x. Okay? That's for the f we talk about, you are familiar with. Now, we are going to change things to u and v. Okay? So if I have u of x, if I take a derivative, means what? U prime x dx. That's the derivative style. If I write a differential symbol, that would be what? du. Right? We mean they are the same thing. I can write the du equals what? U prime x dx. Or I can write a what? du means what? U prime, because u and v are some kind of x. I don't have to specify, I just use prime. Right? Means derivative of against dx. Okay? So that's the symbol we are going to use. Then if I use dv, that means v prime of dx. Okay? So that's the symbol we are going to use for using the what? Differential symbol like this. Okay? So there are many symbols but mean pretty much the same thing. Then we want to take a look how does this come about? Right? So now if I wanted to do something integral like this, I'm going to split the two parts. One is u, one is v. Then one is u, one is v. U is some kind of x, v is some kind of x. Okay? So how we are going to transform this to this and take a derivative? Okay? If I want to take u and v, take the derivative some kind of x, right? It's like if I have u is u of x, v of x, right? I want to take a derivative of this because this is what? A product. Then we use a product rule would be what? U prime x, take the derivative of first one, times the second one, plus what? V prime second one, take a derivative times the first one. Right? So by product rule, what do we have here? This one means what? U prime, right? We are going to use uv directly because they are function of the x. So that would be this plus what? V prime of what? Times u, right? By product rule. Now we are going to take antiderivative of this. So for this one, so antiderivative means what? The integral, okay, against x, right? Should be same here, should be what? U prime v of dx plus what? V prime u dx, right? You take it individually. Okay? Then, what's the antiderivative of this? We say f of x, take a derivative would be what? F prime of x dx, right? Then if you take antiderivative of this one is take a derivative. Then you take antiderivative of this. Should you go back? Right? Now we have what? You take uv together, right? Then you take a derivative uv of x. You take a derivative, that would be what? uv derivative of x, right? Then you take antiderivative of this, uv prime dx. Should you go back to uv? Right? So what you have here is this one will be your uv, right? And this one, take a look, u prime dx. U prime dx is what? du. Okay, so you will write it this way, it will become v du, right? Here. And plus v prime dx. V prime dx is what? dv. So you will write what? v prime dx is what? dv. Become u dv. Right? So your uv is integral of v du plus integral of u dv. Then I will have what? U dv, you subtract this. Subtract on both sides on this. Then what do you have? Right? If I leave this alone, then what do I have? I subtract this over uv minus v du becomes what? U dv. That's the formula, right? Integral of u dv equals what? uv minus integral of v du. Super confusing, right? Okay, so that's the formula. Then the reason behind it, with all those, with differential symbol we are using for those two particularly to derive to those formula, right? It's super confusing, but using it is not too bad, okay? That's how we get this formula, by using what? The product property, product rule, okay? So to get this formula, for the purpose of solving the integral like those, you cannot use substitution, okay? Then let's see how we are going to do it with the formula like this. Okay, so let's take a look. If we have this one, ex dx. Okay, so the steps is this way. We need to convert that to u and v, right? So we have to decide. So the steps to do that is, first you have to decide by parts. You have to split this to two parts. One is u and one is v, right? But we decide by u because we wanted to do this, u dv. So we want to decide the u and dv first, okay? Then from here, we are going to find what? U, you can find the du, dv, you can find the v this way, okay? Then we will use the formula here, okay? Use the formula here and integrate the v du. uv you can just multiply. But if you can integrate this, then you can find this, right? That means if we can make this become this and this, then this one is a simpler one and can be integrated easier, right? Then you find this, you find this, then you find the original one, like here, okay? Then we will replace back and check. All right, and the rule of thumb to find out, decide u and dv. How can we decide? That would be on your page 87, okay, rule of thumb, but not always, okay? When we select u by part, and so the rule is this one. If we have xn, because we have more complicated situation, and ax. If we have polynomial, and exponential function, then we will choose this way. U equals x to the n. We will choose u becomes this part. Then we will choose dv on the remaining, the exponent part. Okay, so this one is what? Polynomial and an exponential function. So if I have xn and log, if I have a polynomial and a natural log function, so we will use u becomes this part, okay, log part, okay, then dv will be your exponential, polynomial part. That's a rule of thumb, okay, in general. If I have a polynomial both, then if I have x plus a to some kind of power, okay, x plus b to some kind of power, okay, we will use u as what? X plus a, the first part, and dv equals x plus b to the nth power, this part. Okay? And if we have a log, then we will use u for the log. Okay? So if we don't have a log, then we will use u as the poly part. Okay? Polynomial. So that's a rule of thumb. Then, for the purpose of our class for business application, we rarely will have you deal with those kind of complicated model. Okay? Then it's extremely confusing and time consuming and energy consuming for you to learn this part. You just have to decide. Okay? You can let it go, still get your ABC, but you have to do everything else almost 100% correctly. So you will have one of those problems in your exam 3 and in your final. Okay, but as we know, you probably rarely deal with those kind of model for your business. All right? So, if we do the example, this one, we are going to do it integrated by parts. So, we have to have one part is what? U. One part is dv, like here, u and dv. Then we will transform it to become uv and vdu. Then this part is easier to integrate. Then we can find the answer from this part. Okay? So, by rule of thumb, we have what? A poly and a exponential. So usually we just use polynomial as u, unless it's a log. Okay, so according to this, then the rule of thumb is like here, right? So you will use what? Your u is x, right? This part. Then your dv will be the remaining part is what? Ex dx. Because my dv this way, I can find the v antiderivative for this easier as what? As a single rule, right? Exponential function. If we do that, right? Then if I do use this dv this, I have to find the v and du, right? Then I need to find the what? Du. Du is what? Dx. Is that right? You take a derivative on both sides. Then if I do this, then v will be what? Integral of this, which is what? You take the antiderivative, right? Which is ex. Is that right? Okay. Then now you have what? This one is your u dv. We should have what? uv minus v du, right? That's the formula. So then what's your u? U is x. What's your v? V is here, right? So the formula says uv, u times v will be x times ex minus v du. What is your v? V is this, right? Ex. What's your du? Du is what? Dx. Is that right? Okay. Then we make this complicated one becomes something multiplied together minus an integral, and that one is much easier, right? So what's antiderivative of this? That would be ex, right? But the indefinite integral, so we will minus what? Ex plus an arbitrary constant. So that will be your answer. That's how it works out with all those things, right? So first you decide u and dv. Then you will find what? Du and the v. Then you use the formula to change the u dv, become uv minus integral v du. Then you can integrate this. Okay? Then do that. Okay? Then check. How do you check? Then you take a derivative of this, right? You will do d dx, take a derivative of this. Then see what you have. Okay? Then you take a derivative of this by product rule. So derivative of x is 1, so that will be x plus derivative of this, still the same. Multiplied by this will be ex, right? Then derivative of this will be minus ex. Then derivative of this constant is 0. So you check, then those cancel out, then you get the ex. So when you take a derivative, then that will be inside. Then you take antiderivative inside will become its original. That's how you check. Okay? Then let's look at the second example. So integral of x squared, natural log x and dx. And so it's a poly and log. From rule of thumb, if you have a log, you let the log become your u. Okay? So you will use this one as your u. Okay? The remaining one will be your dv. Okay? Then to use the formula, we need to find the du. Take a derivative of that. That would be 1 over x. Right? Then take a derivative of, from derivative of v, we have to go back to find the v itself. So v would be antiderivative of this, which is what? Polynomial. Then you just use what? The power rule. Then would be what? X cubed divided by 3. Right? Then we can use that, becomes what? U times V. U times V. Right? So we should have UV will be x cubed thirds times this. That's your UV. Right? Probably I write it this way. 1/3 x cubed x. Right? That's UV. Minus integral of v du. V is this guy, right? V times du. Du is what? 1x of dx. This one should be dx here, right? Because you take against the x, right? U is some kind of x. Du would be the, take a derivative of x. Then what do we have? Then this one cancel out x squared. So I will have 1/3 x cubed natural log x minus 1/3 integral of dx. Right? Then I will have 1/3 x cubed natural log x minus integral this will be what? X cubed divided by 3. So that will be x cubed divided by 3. Right? Up one level plus c. So that will be 1/3 x cubed natural log x minus what? 1/9 x cubed plus c. Right? And let's check. Okay? Then to check, then you take a derivative of this. Dx against 1/3 x cubed natural log x minus 1/9 x cubed plus c. Right? Then you follow the product rule for this. This is 1x, 1 over x. So you multiply them, become 1/3 x squared plus take a derivative of this will be what? 3x squared times 3 times this. Then minus this. Then you should get back to your original. You can do the derivative this to check. Okay? Confusing enough? it's a lot. All right, and let's take a look. So this is for involved with the log. All right, so on the bottom, and like this one, integrate of natural log x cubed to the dx. For this one it's very similar to this one. You have a natural log, right? Then you have x squared, but here is x cubed, take the square root. So what do? You will write this one, right? X to the 3/2 power, and the root. Natural log x and dx. Okay, so will be similar to this. Then you will use u as your natural log. Then you use dv as this 3/2 power. Then you will do the similar way. Once if you involve with the 1 log, natural log, and the 1 x to the power. Okay, so if you have this one, natural log of x, even say x to the 13 power, like this. Okay, so what do? You will do the same thing as x to the 13 to the half natural log x dx. Then you will do the same way. U as your natural log, then dv as your, right, the power thing. Okay? So we did what? Integrate by a Pauli exponential function. So when you use Pauli and exponential thing, you use u as a Pauli thing. Same thing as Pauli and Pauli, except when you have Pauli and the log, natural log, you use u as a natural log. That's the rule of thumb. Okay? So we did this one, we did this one, we did this one. And let's try some Pauli and Pauli. Okay? On your page 87, next example we have is x minus 2 and x plus 4 to the 8th power to the dx. Of course, you can multiply them and write it individually. That will take you forever of your life, right? But if you use advanced skill, you will save your time. So according to this, Pauli and Pauli, it says what? Use u become the one of them. That's good enough, right? So let's see. So our u would be what? X minus 2, right? The remaining would be what? Your dv, okay? dv would be x plus 4 to the 8th power and dx. Then from there, right, we have u and dv, Then we need to find the v and du, okay? So we need to find the du. That would be what? 1. From here, we need to find the v, so v would be integral of this guy, right? Then this would be power higher, x plus 4 to the 9th power, then that would be 1/9. Is that right? Right? Because x plus a is a some kind of number take derivative, we don't need the chain rule, right? Because that's constant. So become, even we use chain rule inside, that would be same thing as just do the x. Because the derivative of constant is 0. So then we say that's our what? U dv, right? U dv. So then we should have what? uv minus v du, right? We should have this. So what do we have? U times v, u times v, right? Should be 1/9 x minus 2 x plus 4 to the 9th power, right? That's your uv, okay? Minus v du. V is this, 1/9 x plus 4 to the 9th power times what? This should be have dx, right? V du. Right? V du. V du. That's that. So that would be, okay, from here. So what do we have? We have this, we take integral of this, become a simple power rule, right? So we have here, we have 1/9 x minus 2 x plus 4 to the 9th power. Take the integral of this, become 10th power, divided by 10, then that will be 90 here, and x plus 4 to the 10th power plus what? A c, right? So that will be your answer. Okay? All right. So we are using the formula. Then we did different kinds. Right? Okay. You can also check, you take a derivative of this, you will end up as same thing as that. Okay? And you use the product rule to do this, and use a power rule to take a derivative of this. When you combine them, you will have this as derivative. Then you take an antiderivative for this, that will be your original function. Okay? All right. Let's see. Here it's in your homework, like this. 2x plus 1 dx. This one doesn't fall through any of those. Okay? But there is another way. In pre-calculus, we simplify this, but you didn't take a pre-calculus. That's how we are going to do. Okay? So we are going to split this, becomes what? We did this actually in the 152A class. It's a long division, 2x divided by 2x plus 1, right? You don't have a number here, so what you have is 1, then you multiply 2x plus 1, this is 0. When you minus this, you get a -1. Okay, so what do we mean by that is you have, say, 20 divided by, say, 3 would be what? 6 and 2/3, right? Means 6 plus 2/3. When they have the same degree, so we can write this as what? You write division, then that would be your quotient plus what? Remainder over divisor, right? It's a lot of algebra. So that would be 1 plus what? -1, the remainder over the divisor. That's actually 152A class, right? We did the polynomials, add, subtract, multiply, and divide. So you have to change this. Then if you don't see it, you actually can put this one will be 2x plus 1 plus -1 2x plus 1. In pre-calculus, they did a lot of practice on those. Okay? But we skip pre-calculus, we just jump to calculus. So then you will have problems with all the polynomials and log and the exponential thing. So what we do is, if this one, right, they are the same, that means we are going to integrate what? 1 plus -2x plus 1 to the dx. Then we do what? The sum and difference rules. So you have 1 dx plus what? Integral -1 2x plus 1 to the dx. Right? Then this one, antiderivative will be just x. Then this one is what? 1 over, if x is in the bottom, right, on the bottom, then you have to use what? This one, natural log what? X plus c, right? That's c. So when you see the something 1 over a denominator that looks like this style, so 1 over x is a natural log, right? So you have what? D, if you take a d dx natural log, you will get a 1 over x, right? Then you have 2x plus 1, so in terms of thinking, you would do d dx natural log what? 2x plus 1, right? Then if you do this derivative, what would you have? You will have 1 over 2x plus 1, because inside it's not just a simple x. You need to use chain rule, so you will do d dx 2x plus 1, then you end up 2x plus 1 times what? 2. Is that right? Okay. Then if you take, then for this one, then that means what? 1 over 2x plus 1 equals, let's do the antiderivative. So for these two, if you do antiderivative of this one, right? That would be natural log 2x plus 1, right? You take derivative is this, then whole thing, you take antiderivative, that would be this. Then if you take antiderivative of this, that would be what? Integral of 2x plus 1 times 2 and dx. Take the antiderivative, right? Then you will take 2 out, then will become 2x plus 1 dx. Is that right? Okay, so what do we have now? So for this one and dx, like here, take antiderivative of this, it will be what? You divide by 2, divided by 2, that would be half of that, right? Would be minus 1, then half of that, you divide by 2, and natural log 2x plus 1. Right? Then, let's see. And with the indefinite integral, you just plus c. So that will be your answer. Right? So for this one, from your homework, and you don't need this integration by parts because you can simplify this to be this way. Okay, become simple constant and the derivative of the log, then you just do the antiderivative. Okay, and next one you might need to do with this integration by parts. Okay, that will be your homework, like natural log 2x plus 1 dx. Right? Then from the rule of thumb, we say if you have the log, then with the other polynomial, you will use the log 1 to be your u. Okay? So your u will be what? The log 1. Right? Then your v will be what? The invisible 1. Okay? Then with that, then we said you need to use uv, right? And the v du. So we need to find the v and du. So from here, your du will be what? Take a natural log of derivative plus the chain rule times 2 and dx. Right? So we just move the 2 to the top this way. That's your du. Then your v is 1. Oh, that's not v. That's dv, right? That's dv. So dv is what? The remainder 1 and dx. Then your v would be integral of the dx. That would be x. Right? So this one is extremely complicated. So we say if the integral you have a log, you make the log as u. The remaining becomes what? dv. Then with u and dv, you are going to find what? v and du. V and du. Then you will transform this one becomes what? U times v. U times v will be x and natural log 2x plus 1, right? Minus the integral of v and du. your v is what? X. And your du is what? 2 times 2x plus 1 dx, right? So it becomes what? X natural log 2x plus 1 minus integral of 2x and 2x plus 1 dx. If you have a single natural log, try to find the antiderivative, the integral, you have to use the integration by parts techniques to do that. Make u and dv, u and dv, find the du and v. So use the formula uv minus integral of v du. End up this way. Then what will happen? Then this guy, v du, is just a polynomial with what? Rational expression, right? Rational function. Then for this one, we just went through this because this integration is possible not by the natural log itself. So this integration, just the rational expression with same level, then you end up use the algebra skill to get that. So that's be that one. So you end up with plus 1 minus what? The whole thing, right? Minus x minus -1 natural log 2x1 plus 1 plus c. Okay, so that would be natural log 2x plus 1 minus x plus half natural log 2x plus 1 plus just arbitrary c. Okay, super complicated. But I would never test you on this for the purpose of this class. But for some of you, if you decide to take a more calculus later, it might be handy to know all this. Okay? So, for the application we are going to do, we will not have such complicated model. So, let's go back to your page 79, example 3, which we skipped last time. At that time, and we haven't learned this new technique for the integration by parts, so we couldn't do it. Now let's take a look. It says finding the present value of continuous stream of income. A business generates income at the rate of 2t million dollars per year, where t is the number of years from now. Find the present value of this continuous stream, okay, for the next 5 years at the continuous rate of 10%. All right, then take a look at your formula for the continuous stream of income, because that's related to your business concept. Say you try to find the present value, okay, you have continuous stream income, say $2 million per year. $2 million per year. What does that mean? Okay, then let's figure out. So, we say your present value, remember, look at your page 78. So present value is what? 0 to t, how many years? That's your continuous stream of income to e to the minus rt to the dt, right? That's accumulated for each year continuously, right? But the relevant to how much equivalent to is equivalent to the present value. Remember we did an example, say you put somebody put $75,000 per year on your page 78 for next 8 years. Then you earn the stream of income 2.8%. And they want to sell you the business for $630,000. Are you going to buy it now or not? So you have to find the equivalent present value to compare with that $630,000, right? So we want to find the present value. So this one is what? You need to use the formula. So 2t million is continuous stream of income, right? So for continuous stream of income, we say what? Future value is what? Your present value times what? E to the RT. Remember that? Instead of periodic accumulation, we use E to the RT, right? The present value. Then, but if it's continuous income, okay, stream of income is not just a fixed one. Then you have to backtrack then to find the present value by multiply of what? E to the negative RT, right? Then not just one future value, because the next 8 years, each year you will have a stream of income. Then we do the integral for it, right? So this question is telling you for next how many years? 5 years. You will have a stream of income, $2 million per year. Okay? So it means what? 1 year after the first year, you have what? $2 million, right? Then second year, after you have $4 million, 3 years, you have what? 6 million. Then fourth year after that, you have 8 million. Then fifth year, you probably have what? 8 million. At the same time, you will accumulate continuous interest rate of what? 10%. That means after this, you have what? 4 years of 10% of the what? Continuous interest, right? Right. Then this one, after that, you have 3 years of this. This one, you have 2 years of that. Then you have 1 year, right? This one, if you get 10 million, it's after 5th year, then you don't get interest for that. But it's continuously. So not necessary to wait at the end of year. Then we say present value. What do we need to do? So present value will be what? Use this formula, 0 to 5. Then continue. So your y is this, right? That's your c of t. So that will be c of t is 2t. 2t times to what? E to the negative r is what? 10%. 10% is what? 0.1 t dt. Okay? So you have this model, which is what? With the polynomial, with the exponential function, right? Then with Poly and exponential, usually as a rule of thumb, we say what? Which one will use as your u? The polynomial. So your u is what? 2t, right? The remaining things will be your dv. So dv is what? E negative 0.1t of dt, right? Then from there, we want to find the dv and du. So du will be what? 2, take a derivative, right? 2 dt. Then this one, we want to find the v, so we need to take an integral for that, right? So it's just a simple exponential function. Then with the chain rule, you have to divide by what? So you will have e negative 0.1t divided by negative 0.1, right? Which will be what? Negative 10, right? Divided by 0.1t. Is that right? Okay. So we will use this to plug in u and v. So what's u? dt. So that would be 2t, right? Times this, negative 10 e negative 0.1 t, right? That's uv. Minus this one, integral of v, negative 10 e 0.01 t of du. du is what? 2t, right? 2 dt. Okay, so also that's what? 0 to 5. Is that right? So, okay, so that would be what? From 0 to 5, right? So we simplify this one. That would be negative 20 t and e to the negative 1t, right? And here, let's see, integral of this. You need to take integration of this first, okay? So that would be what? This one would be, you take a negative 20 out, would be positive. So that would be positive 20. Then you take integral of this one divided by negative 0.1, right? So that would be what? Negative 200 e to the negative 1t. Is that right? Pretty messy, huh? So that would be what we are talking about is negative 20t e to the negative 0.1t minus 200 e to the negative 1t. Is that right? Then we do from what? 0 to 5. So you plug in the number, that would be negative 300 e to the 0.5 plus 200. Okay, plug in your number. So you calculate that it's around 18. So what is saying, if you have a stream of income, 2 million, 4 million for next 5 years, okay, which total add up is what? 10, 20, 30 million, right? But 30 million down the stream in 5 years, which is what? equivalent to 18 millions of income. So it's saying is what? The present value of the stream of income with what? 2 million per year over 5 years, which is what? Equivalent approximated what? 18 millions as today. Okay? So, let's do some analysis. Right? So you can relate why it's 18 million. Okay? If you plug in present value to here, if you plug in that, then your future value equivalent to what? 18 millions to the e to the 0.1 to how many years? 5 years. See how much the future value will be. Okay? That will be very close to this add up. Okay? If you do the analysis, okay? So if you plug in this, it's equivalent to what? 29.69 million. Okay, but for 5 years, equivalent to today's value is what? 18 million with what? 10% of the continuous compounding, right? Then would turn out to be 29.69, which is what? About 30 million here. If you look at each one individually, okay, we just use the half year. So because it's continuous stream of income, so for the first 2 mil, right, the average between that year is what? Okay, so would be, instead I use 4 year, I will use what? 1 million average, right? In between that, that would be what? 4.5 year. Is that right? Then next one, I will use what? Because 4 million during the second year, that means 3 million in between for 3.5 year. Then this one, that will use what? 5 million. That's how you do analysis. So 2.5 year. Then this one you will do what? That would be 7 million stream of income. Average would be what? 5.1 year for the interest, right? Continuous interest. That would be 9 million for what? 0.5 year, right? Then if we do the future value is what? Present value times e to the RT. So for this one, for the future value, 1 million first year, right? Then for 4.5 year, so that will be 1 times e to the what? 0.1 times 4.5, right? Then this one will be what? 3 times e to the 0.1 times 3.5. Then this one will be 5 million e 0.1 times 2.5 this one would be 7E.1 times 1.5. That will be the total income for the future value, because along the way you accumulate the, interest. So E.1 times 0.5. When you add all this up, it's about 29.83 million. Okay, so you can see if you have continuous income like this, 10, 20, 30 million, right? But the last one, you don't accumulate interest on that. So if you do the analysis, it will be about that much by the end of 5th year. Okay? And this one, if you consider 18 million as a current value, present value, you accumulate that 10% of interest. By then, you will have what? 29.69 million. Okay, that's how you do the analysis. Then this is how you calculate your present value by a stream of continuous income. This way, use this formula, use this model. Then at the same time, you need to calculate the present value. You have to use the new technique of integration by parts to figure out. Okay, so if you are in the more financial world, later on, you want to figure out those complicated things, it might be handy. Okay, so that's our section 3.5, integration by parts.